The triangle inequality theorem is one of the fundamental mathematical principles concerning the sides of a triangle. The core concept of the triangle inequality theorem is as follows. In any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. Assuming we have a triangle ABC with three sides denoted as A, B, and C, the following inequalities hold. A plus B is greater than C, B plus C is greater than A, C plus A is greater than B. This theorem describes the relationship between the lengths of the sides in any triangle. If the lengths of the two sides 5 and 14 of a triangle are given, you can use these inequalities to determine the length of third side. 5 plus x is greater than 14, x plus 14 is greater than 5, and 14 plus 5 is greater than x. X is greater than 14 minus 5, second inequality is always true, and 19 is greater than x. Let's combine solution sets. First solution set is x is greater than 14 minus 5, and the second solution is x is less than 19. The solution of a system of inequalities is overlapping region. Therefore, x is greater than 9 and less than 19. However, these alone cannot determine whether the triangle is right-angled, acute-angled, or obtuse-angled. To distinguish between acute, right, or obtuse triangles, you need more information regarding the lengths of the three sides. Let's examine the relationships among the three sides A, B, and C of a triangle. Right triangle. To establish a right triangle, you must apply the Pythagorean theorem. It must satisfy a squared plus b squared equals c squared, indicating the presence of a 90-degree angle. Acute triangle. An acute triangle has all angles less than 90 degrees. Therefore, if C is the longest side, it should satisfy the inequality a squared plus b squared is greater than c squared. Obtuse triangle. An obtuse triangle has one angle greater than 90 degrees. If C is the longest side, it should satisfy the inequality a squared plus b squared is less than c squared. Thus, using information about the lengths of the three sides, you can determine if a triangle exists and whether it is right-angled, acute-angled, or obtuse-angled. See you next time.